Alright, so today we'll be talking about probability of multiple events. Okay, so first off, let's start getting some definitions down. Dependent and independent. Okay, so dependent is when one occurrence affects the outcome of the second event. Okay, let me change that real fast. I was typing a little bit too fast. See, ladies and gentlemen, this is what happens when you type too fast. Okay, so for example, if you had a deck of cards, 52 cards, and you drew out some cards and left them out as you drew out more cards, the probability of the other cards happening are affected by those first couple of cards taken out. So that's a dependent event. Okay, an independent event is when the outcomes are unaffected by one another. Okay, so in other words, like let's say for example, I was rolling some dice and then spinning a spinner on a spinner. It's for a number. The dice do not affect the spinner, so therefore those are independent. Okay, so now if we have two events, let's say A and B are independent, okay, then the probability of A and B happening, okay, so event A and event B happening is equal to the probability of A happening times the probability of B happening. Okay, and let me make that a big A, because whenever you're working with probability, capital letters represent events. Okay? Alright, now two events that cannot happen at the same time as mutually exclusive events. So in this case, if A and B are mutually exclusive events, okay, in other words, like if A was when you're rolling dice, if A was getting a 2 and B was getting a 6, well, if you roll dice, you either get 2 or 6. You don't get 2 and 6. Okay, so that probability is actually A and B is equal to 0. Oops. Okay, so that probability is flat out 0. It does not happen. You cannot get it. Okay, now what about the probability of A or B? So if A and B are mutually exclusive, okay, the probability of A or B happening is equal to the probability of A plus the probability of B. Okay, let me make that a big A. There we go. Okay, so this is the one where you add. So a lot of math teachers like to call this the and you times and the or you add. But it depends upon if it's mutually exclusive or if they're independent, that type of stuff. Okay, so now if we're just talking about if they aren't mutually exclusive, they're just events that happen. Okay, so the probability of A or B happening is equal to, now this one is a lot like the probability of a mutually exclusive event. Okay, except in this one we're going to subtract the inclusion of both. Okay, and I'll explain why we subtract in a second. Okay, and this has a lot to do with Venn diagrams. Okay, so let's say we were rolling dice, just simple stuff right now. Okay, and let's say we were rolling even numbers. Okay, and so all the even numbers that are in there are 2, 4, 6. Okay, but we also want, let's say we were dealing with a situation where it's a multiple of 3. Okay, numbers that are multiple of 3 is 3, 6, right there. If you notice, 6 is repeated twice. Okay, so we would move 6 to that middle, and then we would move this 6 and delete that. Okay, So the number of multiples of 3 or 2 of them could happen, and the number of even numbers on dice are 3 of them that could happen. Okay, so if you notice, this is not mutually exclusive. So when you see mutually exclusive, you would see nothing in the middle when you did a Venn diagram of it. So this is why Venn diagrams are so helpful, because they help us count objects or elements and sets and stuff, and they just help work out. Okay, now if I did the probability of A, okay, the probability of A would be 3 out of 6. Okay, there's 3 even numbers out of 6, and then I add that with the 2 out of 6 for the second number. But if you notice something, I'm actually counting 6 twice. Once for the even numbers and once for the multiples of 3. So when I count it twice, I have to subtract it once. And that's where this minus, this 1/6 comes into play, because I accidentally counted it an extra time. And so when I do it, 3 plus 2 is 5, minus 1 is 4, so this is 4/6, which reduces to 2/3. Okay, so the probability of getting an even number or a multiple of 3 is actually 2/3. Okay, so when in doubt, make a Venn diagram. Make a Venn diagram. It'll make your job a whole lot easier. That's why it was invented. Okay, look for the fact, is it mutually exclusive? And if it is, the probability, and we call this the intersection, is going to be 0. Okay. Alright, now OR is just going to be everything added up. If you notice, if I just counted up these items, 1, 2, 3, 4, that would get me that item real fast out of the total numbers. Okay, but I strongly recommend when you're doing multiplication, the probability of A and B, you just have to be very careful just to work with it. Okay, alright, that is it for this. Oh shoot, let me just show you it actually. Okay, so let's find the probability of an even and a multiple of 3, and I'll show you how it actually works out. Okay, alright, so that's going to be the probability of an even number is 3 out of 6, and we're going to times that by 2 out of 6. There's multiples of that. So what we're going to get is 6 out of 36, which if you notice, if we reduce, this turns into 1/6, which makes sense because there's just one item in there. Okay, alright, and that's the probability of multiple events. You're going to see a lot more complicated stuff to work with, but if you just pay attention to these rules as you go along, you should be totally fine. Thank you and have a great day. Bye.